On question number 5, we're trying to find the partial fraction decomposition. And our first step is to factor the denominator. So I can factor out an x, and that leaves me with an x squared minus 2x plus 1. And then I can factor that further into x times x minus 1, x minus 1. So this is x plus 2 over x times x minus 1 squared. And this term right here is what's called a repeated linear term, meaning we have an x on the inside of the parentheses and we have more than one of them. We have an exponent of 2. So whenever you have a repeated linear term, it's going to change our template for how we do the partial fraction decomposition. So it's going to be x plus 2 over x times x minus 1 squared, and this will be equal to a over x plus b over, now we need to actually build up into the x minus 1 squared. So I need to include one of every power that's less than the squared. So this will be x minus 1 and then plus c over x minus 1 squared. And I want to talk a little bit about why that is. So I'm going to take a break from this problem and kind of talk about why we need to do that, why we need to build it up. So let's say you had something over x plus something over x minus 1 squared. Well, the LCD is x times x minus 1 squared. However, if you had something over x plus something over x minus 1 plus something over x minus 1 squared, the LCD would also be x times x minus 1 squared. So because we need to account for this potentially being there, that's why you have to have this term, and that's why you have to build up into it. So if it were x times x minus 1 to the 3, you would need something over x minus 1, something over x minus 1 squared, and then finally build your way up to x minus 1 cubed. So that's how we treat these repeated linear factors. Okay, so then I'm ready to multiply by my LCD. So that's going to leave me with x plus 2 is equal to a times x minus 1 squared, because my x's go away, plus b times, I'm going to have an x and an x minus 1 because this x minus 1 only cancels out with one of those x minus 1s, plus cx because x minus 1 squared cancels out with x minus 1 squared. So I want to do some simplifying. So I FOILed that out. Now I want to distribute. Okay, so now I want to group my terms. So I want to group my x squared terms together, my x terms, and then any terms that don't have an x. So I'm just reorganizing my terms. And I'm doing this because now I can factor. So I have x plus 2 is equal to x squared times a plus b plus x times negative 2a minus b plus c. Then I have plus a. So now we want to equate our coefficients. So on the right hand side I have a plus b being multiplied by x squared. And on the left hand side I don't even have an x squared. So if you wanted to, you could put a 0x squared if you wanted to. So our x squared equation is going to be a plus b is equal to 0. On the right I have all of this being multiplied by x, and on the left I have a implied 1 there. So I'm going to, for my x equation, have negative 2a minus b plus c is equal to 1. And then for my constant, I have an a and I have a 2. So for my constant equation, it's going to be a is equal to 2. And I'm going to put this system of equations into a matrix. And then do the reduced row echelon form and get 2, negative 2, 3. So I need to put those over top of my different factors. And that will be my answer.